So let's start with a parabola. Let's first draw a parabola. A parabola looks like a letter U, but with a wider opening. It's actually a curve formed where any point on the parabola or the curve is equidistant from a fixed point called the focus. Let's assume that the coordinates of the focus is 0, 2. It is also equidistant from a fixed line called a directrix, which is y is equals to -2 in our case. There is this line that equally splits the parabola into two. This line passes through the focus, is perpendicular to the directrix. This is called the axis of symmetry. Here is your vertex. The vertex is a point along the axis of symmetry, which is exactly midway the focus and the directrix. Moreover, the distance between the vertex and the focus is equal to the distance between the vertex and the directrix. Now, this line segment that passes through the focus and is perpendicular to the axis of symmetry is called the latus rectum. It has both endpoints on the curve. Any point on the curve of the parabola has an equal distance to the focus and to the vertex, which is denoted by the lines drawn here. Now, enough with the definition. Let's now deal with the equations. We will use the conics or vertex form, which is the quantity of x minus h squared is equal to 4p y minus k, where p must not be equal to 0. Let's first have an example. The quantity x plus 1 squared is equal to 8 multiplied to the quantity y minus 2. The vertex of the parabola lies at point hk. We have x plus 1, but the form of parabola must be x minus h, so it's going to be x minus -1. We are changing the sign because the number here is like multiplied to -1. On the other side of the equation, we have y minus 2, so our k is 2. In this example, our vertex is the point -1, 2. Now let's find the focus. The focus of the parabola is h, k plus p. P is the distance between the focus and the vertex. It is added to the y-coordinate because this parabola has a vertical axis. This will be more evident when we graph the parabola. Let's first find our P. For the units, the vertex is translated from the vertex of the parabola. We will first equate the given formula with the standard formula. By doing so, we will get 4p multiplied to the quantity y minus k is equal to 8 multiplied to the quantity y minus 2. We will substitute the value of k to the left side of the equation and get 4p y minus 2 is equal to 8 y minus 2. We then divide both sides by 4 multiplied to the quantity y minus 2. This will give us the value of p, which is 2. Going back to the formula for our focus, we have h or -1, k or 2 plus 2. By simplifying it, we will get -1, 4. Let's graph these given points in order for us to be able to visualize these points more clearly. Our vertex is at -1, 2, while our focus is at -1, 4. From here, we can say that the graph opens upward because in a parabola, the vertex is always on the parabola, while the focus is always inside the parabola, and the directrix is outside the parabola. Speaking of the directrix, since it is outside the parabola, we can say that it is below the vertex. We should also note that the distance between the vertex and the focus is equal to the distance between the vertex and the directrix. We can derive that the formula for the directrix is y is equal to k minus p, since p is the distance between the vertex and the focus. Since our p is 2, our directrix is y equals 2 minus 2. By simplifying it, our y is equal to 0. Let's determine our axis of symmetry. It's the line x equals h. Since h is -1, our axis of symmetry is the line x equal -1. The length of our latus rectum is the absolute value of 4p. Since rp is equal to 2, the length of LR is equal to 8. Let's draw a line that passes through the focus and is equal in length on both sides of the parabola. The formula for its endpoints is h plus or minus 2p and k plus p. Add and subtract 2p from our x-coordinate because the 2 points are aligned in the x-axis. The y-coordinate is k plus p because it is on the same line as the focus. Through substitution, we get negative 1 plus or minus 4, 2 plus 2. Once simplified, we get negative 5, 4, and 3, 4. And this is how our parabola will look like. Here is a table that summarizes the properties of a parabola. On the left side are the equations for parabolas with vertical axis. These parabolas have the squared part on their axis. On the other side is the formula for parabolas with horizontal axis. The y part is squared in this type of parabolas. You can pause the video if you want to examine the properties more thoroughly. Let's have an example for the other type of parabola, the horizontal parabola. Basically, the concepts are just the same. The vertex for this parabola is hk, or 1, 2. Let's plot that point first. Our graph opens sidewards, either to the left or to the right. Let's first determine our focus. Since this has an x-axis, we will add the p to the x-coordinate, or the h. Since 12 is equal to 4p, p is equal to 3. Therefore, our focus is 1 plus 3, 2. By simplifying it, we get 4, 2. When we plot it on the Cartesian plane, we can see that it is on the right side of the vertex. We can therefore conclude that our parabola opens to the right. Our directrix is x equal to h minus p. By looking at the graph, we can say that the distance between the vertex and the focus is 3. Therefore, the distance between the vertex and the directrix is also 3. We can graph the directrix by creating a vertical line which is 3 units to the left of the vertex. Going back to our equation, x equals 1 minus 3, or x equals negative 2. This is consistent with our graph. For the axis of symmetry, we have y equals k, or y equals 2. We will graph it in such a way that it passes through the focus and the vertex and is perpendicular to the axis of symmetry. The length of our LR is equal to the absolute value of 4p. 4 times 3 equals 12. This means that the distance between the two endpoints is 12. Since the focus is there midway, we can say that from the focus, the distance of an endpoint is equal to 2p. Coordinates of the endpoints of the LR is h plus p, k plus or minus 2p. Substituting the values, we get 1 plus 3, 2 plus or minus 2 times 3. This is equal to 4, 2 plus or minus 6, which later equates to 4, 8, and 4, negative 4. Graph of the parabola looks something like this. Let's try a different approach. Suppose that the given vertex is 5, negative 2, and the directrix is y equals negative 5. Asked to give the equation for the parabola. Let us first plot our points. Here is the focus and here is the vertex. Since we know that the directrix is outside the parabola, we can say that the parabola opens upward. Therefore, the base of our equation is the quantity of x minus h squared equals 4p applied to the quantity y minus k. The distance between our vertex and our directrix is 3. Therefore, our focus must also be units from the vertex but on the different side. We can say that our focus is at the coordinates 5, 1. We can substitute the values we acquired to the standard formula. Our vertex is 5, negative 2. We can easily substitute it to our HK. We can also substitute our P, or the difference between the case of the vertex and the focus. Our P here is positive because we know that our graph opens upward. We will get the equation, the quantity of x minus 5 squared equals 12 multiplied to the quantity y plus 2. Let's explore further. The length of our LR is the absolute value of 4p, which is 4 times 3, or 12. This means that the endpoints of our LR is 6 units to the right and 6 units to the left. Specifically, the coordinates are 11, 1 and negative 1, 1. Also get this by substituting the values to h plus or minus 2p, k plus p, or 5 plus or minus 2 times 3, negative 2 plus 3. This is equal to 11, 1 and negative 1, 1, which is similar to the points we obtained. We can now draw the parabola.